Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome to our thesis presentation. First of all, I would like to thank our Honorable Board of Examiners and Teachers for allowing us to present our thesis. Our thesis was supervised by Mr. Muhammad Mominul Haq, Assistant Professor of CE. Me, MD Jaman, along with other three group members, will present the thesis. Our presentation is divided into the following topics. I will present up to a statement of the problem. Sabir Ahmed will present laboratory investigation and data interpretation. Sharif Ryan will present result and discussion. Remaining topic will be presented by Shohanur Rahman. Our thesis topic is the application of dynamic cone penetrometer for the quality control of improved subgrade layer. The specific objective of this research are to develop relationship between DCPT bolus and dry unit weight, as well as DCPT bolus and relative density of improved subgrade soil. For any gives value of DCPT bolus, dry unit weight and relative density can be estimated from the relationship. The relationship can be used to quality control of improved subgrade layer. Due to the poor quality of subgrade severe, most of the pavement works required an improved subgrade layer in Bangladesh. The improved subgrade layer is required to compact to a relative compaction of 95% and above to compare to the maximum dry unit weight measure in the laboratory standard or modified Proctor test. After compaction, the quality is controlled. That means field dry unit weight is measured by means of sand cone method. But sand cone method required both field and laboratory measurement, hence it is time consuming and uneconomic. On the other hand, dynamic cone penetrometer is extensively used to estimate of subgrade CBR. That means strength of subgrade layer. The CBR value is estimated from the standard DCPT penetration and bolus relationship. The dynamic cone penetrometer is a simple and handle equipment, quite easy to operate compared to the sand cone method. It required only field measurement, hence time saving and cost effective. So in the research, an attempt has been made to develop the relationship between DCPT bolus for a specific penetration depth and dry unit weight as well as a relative density of improved subgrade soil. And the relationship can be used for a quality control. In this study, improved subgrade soil sample was collected from the Bus Rapid Transaction Project, Gazipur. I am requested my next presenter, Sabir Ahmed Bhuiya, to continue this presentation.
Thank you, MD Rashid Jaman. Now I continue this presentation. After sample collection, different tests were conducted for the determination of index properties, such as grain size analysis, specific gravity, minimum and maximum dry unit weight, test by using Bibliography table. Besides standard Proctor test were performed to estimate maximum dry unit weight and optimum moisture content. The data from index testing were used to prepare sample for dynamic cone penetration test. The results obtained from the laboratory test are listed in the following table. The collected soil is a polygram sand and having fineness modulus and specific gravity of 1.52 and 2.66 respectively. Minimum and maximum dry unit weights were found 13.88 and 17.04 kilonewton per meter cube from Bibliography table test. From standard Proctor test, maximum dry unit weight and optimum moisture content were found 17.05 kilonewton per meter cube and 12.15%. We perform both Bibliography table and standard Proctor test to estimate maximum dry unit weight of soil because it is essential parameter for the preparation of specimens for DCP test. Maximum dry unit weight obtained from both tests are almost same. For dynamic cone penetration test, specimens were prepared 91% of maximum dry unit weight. Obtained from library test, the range 90 to 1% is selected because root construction specifications require more than 95%. Compaction in the field compared to dry unit weight obtained in the laboratory test. A 147.32 mm diameter and 304.8 mm high mold was used for specimens preparation. The specimens were compacted in 6 equal layers. An equal compactive effort using standard Proctor hammer and targeted density achieved by trial and error. After sample preparation, the dynamic cone penetration test were performed to gauge density of obtained number of blows required to penetrate. A depth of 152.4 mm, top 76.2 mm was ignored because of lack of confinement. Next, 152.4 mm depth was considered for penetration depth, which is enough to represent the field condition. DCP were performed on 10 samples in the range of 90 to 100% relative densities. In other words, 90 to 100% of maximum dry unit weight. The sample were prepared by increasing the density not more than 2%. The following graphs are representing DCP penetration versus DCP blow in the range of 90 to 96%. The following graphs are representing DCP penetration versus DCP blows in the range of 96.3 to 99%. And the following graphs are representing DCP penetration versus DCP blows in the range of 99.3 to 100%. From the DCP blows versus penetration plot, the DCP blows are estimated for 152.4 mm penetration. For this particular graphs, it can be seen that for 152.4 mm penetration, the DCP blows is 5.28. I am requested my next presenter Khondokar MD Sharif Rahan continue this presentation.
Assalamu alaikum. Thanks Sabir Ahmed Bhuya. Here we see result and discussion. In the first figure, we can see that the DCP blows 152.4 mm penetration versus dry unit weight. Then the DCP blows for 152.4 mm penetration are plotted against dry unit weight of the experiments to develop the relationship. From the graph, it can be seen that the DCP blows for 152.4 mm penetration produce a linear relationship with dry unit weight, a high coefficient of determination of 0.9898. So for any known values of DCP blows, the dry unit weight can be estimated from this graph. In another graph, we can see the figure of DCP blows 152.4 mm penetration versus relative density. A similar relationship is also developed for DCP blows with the relative density for the same specimens. From the graph, it can be seen that the DCP blows per 152.4 mm penetration produce a linear relationship with the relative density with a high coefficient of determination of 0.9899. So for any known values of DCP blows, the relative density can be estimated from this graph. Thanks everyone. Thanks for listening me with patience. Now I am requested my next presenter Mohammad Swanur Rahman to continue this presentation.
Thank you, Sharif Rehan. Now I continue the presentation. Conclusion. In this study, two relationships have been developed. One is DCPT blows versus dry unit weight and another is DCPT blows versus relative density. Both are linear relationship with a high coefficient of determination, and it is expected that both relationship can be used for the quality control of improved subgrade layer. Recommendation. It was a laboratory based investigation, so field study may be conducted to find out the validity and effectiveness of the correlation in future research. Also, how sample change can affect the correlation may be investigated. Acknowledgement. We would like to acknowledge Engineer Polash Ahmed Ismek, Bangladesh, for providing the soil sample of this study. Also, special thanks to Mr. Ahadullah, Lecturer, Department of Civil Engineering, for helping us with the minimum and maximum density test at Geotechnical Engineering Laboratory of Buet. Thank you for your patience and listening to us. If you have any question, please feel free to ask. We would love to answer.